Okay, there we go. Good morning and welcome to the Vermont Stormwater Management Manual Training Program. We're so happy you could join us today. For those who don't know me, I'm Christine Doherty, Stormwater Coordinator, Town of Williston, and currently seated as a board member of the Green Mountain Water Environment Association, which is the organization that brought watershed consulting and civil engineering in today to bring you this valuable training. Please feel free to message me during one of our breaks if you're interested in learning more about the Green Mountain Water Environment Association. A couple quick housekeeping items for this training. This training is going to be recorded. I do need to let everybody know that. If you're taking this class for professional credits, we ask that you please put your name in the comment box at the start and the end of each day so that I have a list of who's in attendance. Please keep yourself on mute unless you're speaking. Questions can be asked of the presenters through the chat box. We ask that you withhold any questions, spoken questions, until you're provided an opportunity by the trainer. There will be opportunities to ask questions directly. With that, I'm going to turn it over to Andreas, Principal of Watershed Consulting. Andreas, it's yours.
Great, thanks, Christine. I hope everybody can hear me okay here. And yeah, I'd just like to say thanks for everybody also joining this. You know, the first time we did this training was a live training, and since the world has changed, you know, here we are doing it virtually, and we hope that you guys are going to get just as much out of this training as the live version. So, you know, Dave and I are really going to try to make this as classroom-like and interactive as possible without making it confusing. And so that's why we've decided to, you know, at these specified times in the presentation, we're just going to pause. And if anybody has any questions, you could start, you know, your question in the chat, or you can unmute and ask the question, and we can hopefully just get into, you know, a dialogue a little bit, because that's really the goal of this, I think, is we need to have that collaborative question and answer period, because there's, you know, some of this stuff is not black and white, and it's good just to kind of talk it through and get other people's perspective, and you always learn a lot that way, I think. So I'm going to just go over, you know, what the goals are here, and I'll give you a little background on myself and tell you kind of what the plan is for today and tomorrow. And then I'll let Dave Marshall from Civil Engineering Associates introduce himself as well. And then we'll kind of get going on the first module of the training. So really the goal of for today and tomorrow is to familiarize ourselves with Vermont operational stormwater permit requirements, really with a focus on the 2017 Stormwater Manual, which I think for some of you now is, you've been getting more familiar, definitely more familiar probably than the first time we did this training, which was just about a year ago. But still definitely some changes for those who have been working in 2002 manual, which was the last manual. There's definitely some important changes. And then also people just newer to the fields, getting into stormwater, right, with the 2017 manual. So that's really geared towards both of those people. Really, and we want to go towards take you kind of through the whole process, which is the design, the planning, the permitting, the implementation, and then the operation and maintenance. And we're going to get into more of the operation and maintenance, reporting, that kind of thing tomorrow. And really just focus on some of the fundamentals in the manual today. So my background, I've been doing stormwater, working with the stormwater manual in Vermont for about 19 years, soon to be 20 years. And so I've been working on a range of different sites, small residential sites, commercial sites, industrial sites. And so I feel like I've seen a lot of the gray area things that come up, and seen kind of how some of these things translate on the ground, and also as they work kind of through the process of review. And so that's my background. And then Dave, do you want to just say a few words about your background?
Well, I'm probably one of the dinosaurs in the room here. I remember the days when the stormwater rules were only 8 pages long. So they have matured quite a ways for the better in regards to the environment. And as far as our general civil engineering firm, we deal with contractors all the time on the construction end in regards to implementation of intent and execution of the requirements set forth in the stormwater rules, which in theory are all on our design plans when we give them to them. So it's always important to be able to ensure that that communication component is properly executed. This has been a continuingly evolving component of what we do and ultimately what we're seeing as far as the products in the field. So that being the background, we'll have Andres take us to the next level of the presentation today.
If anybody has any issues too, technical issues, just write it in the chat. I noticed Dave was a little quiet on my end. If my audio is good or somehow annoying, just let me know in the chat. So in terms of who we have here, I mean, I've kind of seen a lot of the names come through, and it looks like, I'm just curious to know if you guys wouldn't mind just putting in what your background is. That would be great. I'm curious because, you know, the manual is really geared towards obviously the engineer, you know, producing designs, permitting designs, but it's also geared towards other people who may have an interest in an application, right? So, you know, the municipality or nonprofit group, which may be concerned or just interested in providing comment on a project, you know, and there could be other people as well with interest, just public interest, you know, boards, that kind of thing, local boards. So it's looking like we do, you know, similar to the last version. I think the last version was a little heavy on engineer. This one, it looks like we got RPC, engineers, municipal, conservation districts, consultants. So I guess a mix, and really, you know, the teacher, great, stormwater consultant. So, you know, hopefully this is going to be interesting for everybody. I think that there are going to be some sections which are going to be repeat information for some, new for others, but we'll just try to get through as much as we can. I don't know why it's saying testing out what Zoom. Can you all see that on your screen?
So I'll jump in, Dave Marshall. Hopefully you can hear me better.
There we go.
I had a microphone issue earlier, so we'll correct that. Thank you for the heads up. Saw that in the chat room. So we'll proceed accordingly, and hopefully it'll make sure that we don't have to get any more reminders as far as my microphone. Thanks.
So this is a loaded question. Everybody's favorite BMP. I think the dinosaurs in the room may be geared towards the wet pond. Wet ponds back in the Stone Ages of the 2002 manual were the go-to BMP, right? And I'm saying BMP, and I did this the last training too. The new manual refers to stormwater practices as STPs, not BMPs, STPs. So I'm gonna try my best to call them STPs. So wet ponds, as I was saying, were the go-to. Swales also the go-to. Now, a lot of the focus is more on gravel wetlands, bioretention, green infrastructure approaches. And so that's going to be kind of the focus also of this manual. The way it's set up is it's set up to basically guide you towards those practices. So the plan for the day, we're going to be here until noon. We're going to definitely leave some time at the end just for an open Q&A. And there's going to be some Q&As as we go as well throughout the morning session. But we're really just going to focus on when does the manual apply, and then working on designing with the manual. So going through the foundation of the manual, what the specific criteria are. And then the rest of the session, which is going to be day 2, is going to be starting on the hands-on exercise. So that's going to be day 2. Ongoing permit compliance, planning and designing for existing sites, and then future changes and updates at the end when we wrap up. And one thing to just know, we did send around some learning information ahead of time, which you all should have. And there's a couple documents in there which will be useful. One is the agenda, which I'm putting up right here. And the other is a series of handouts. And we're not gonna actually get into the handouts today. This is all gonna be on day 2, but if you just wanted to start looking through this and familiarizing yourself with these handouts, these are gonna be needed tomorrow when we go through the exercise. Okay? So with that, we're gonna start just from square one. So when does the manual apply? So this is a screenshot right from the state's website, Stormwater website. And there's a lot of things stormwater now in Vermont. It's amazing how it's changed since I've been involved with new programs, municipal roads programs, multi-sector general permit programs, MS4 programs. We're focused on the operational permits. And the operational permits currently are 90-30, 90-15, 90-10, or INDS. We're in a state of change right now. The 90-50, which is the first one listed there, is going to be the only operational permit. Everything is getting funneled into the 90-50. The 90-50 signed September 1st, 2020, going into effect December 1st, 2020, is going to change a lot. I think hopefully simplify a lot in terms of corralling all these permits with all these numbers and kind of streamlining it and making it simpler for everybody to track. So that's really what we're focused on. And when the 90-15, 90-10, soon to be 90-50, when the operational permit comes into play is a couple different scenarios. And we're gonna just run through these scenarios together here. And then we're gonna save some time after this to answer some questions and chat about this, because there's certainly some odd situations that come up. I think the simplest one is where you have a new development which has 1 or more acres of impervious surface. And you're creating that impervious surface, you'll need a permit. After July 1st, 2022, the threshold is gonna go down to 1/2 an acre. We also have a lot of situations where we have a smaller development which may have less than 1 acre of developed land, and we're expanding to 1 acre or more of developed land. You're in a permit situation there. We also might have an existing site which has more than 1 acre of developed land, and now you're adding at least 5,000 square feet of new impervious surface. And so even though that existing site may have been in existence for quite a while, if you're expanding off of it and creating this 5,000 square feet of new development after July 1st, 2005, that new development would need a permit. Then you get into a situation where you have a redevelopment. So you have an existing site, an acre's worth of impervious surface, and you're suddenly converting that now to 1 acre of developed land. And I think just take a note here just to make a special note on redevelopment, because redevelopment I think is one of these gray areas that comes up a lot. Is it redevelopment? Is it maintenance? That's a big question. And I think the easiest way to interpret that is, and there is a definition in the rule which just specifically describes what redevelopment consists of or doesn't consist of. But I think in terms of, say, a parking lot, it's really when you're doing a full depth reconstruction of the parking lot and you're modifying the drainage. So if you're adding catch basins where there was sheet flow, or you're taking one parking lot which drained one way, now you're draining it the other way, and you're going down into the sub-basin and rebuilding the parking lot. That's redevelopment. Same situation if you have a parking lot and you're putting a building. It's redevelopment.
Andres, Dave Marshall here. One thing that we ran into that Kevin Burke helped us with was we were rebuilding a city street in Winooski, and the definition from Kevin was anytime you are replacing or redeveloping the top 6 inches of an existing structural surface, that was where they felt that either you could simply consider it redevelopment or actually new construction. So that was a refinement of the definition in regards to where one particular activity could be considered redevelopment versus totally new construction. Because the standards as far as how hard you have to work to basically deal with the treatment of the stormwater runoff that perhaps didn't have any practices in place prior is different between redevelopment and new construction.
Yeah, that's a good point, Dave, and I think that also goes to the fact that there's definitely some interpretation in these, and you know there's some, it's worthy of a discussion with the reviewer, obviously, about some of these things. As Dave was saying, you know, that was a discussion with Kevin. Kevin, unfortunately, he's not with us today yet. I mean, somebody from DEC may jump on at some point during the training, but it's yeah, it's definitely not always black and white. Also have some, you know, situations where you might have a site with less than 1 acre of developed land, and now you are redeveloping it and also expanding it so that you have an acre of developed land. So it's both the redevelopment and new development combined. You're in a permanent situation in that sense too. And then there's any other situations, you know, the agency actually does reserve the right to issue a permit even if it's less than 1 acre of developed land, if there's a reason that it's deemed necessary by the secretary in terms of, you know, an imminent threat to water quality. There is the right to issue a permit. So it seems like pretty much whenever you're guessing whether or not there's a need for a permit, it seems more and more likely that it needs a permit. In my experience, pretty much everything needs a permit, especially if it's tied to any kind of an existing development. It seems like you're probably in a permit situation. And I think as we go down to a half an acre of impervious, you're going to be getting into situations where even small developments, you're going to be into you know, tripping the threshold.
Hey, Andres, Dave here again. I just got word that Win Wilson has joined us on behalf of Kevin, so we may put Win on the spot on a couple of questions, or he may be here to correct us, as he often does, with regard to interpretation. So Win, thanks for chiming in on the chat box.
That's great. Thanks for jumping on, Win, and feel free to interrupt me or correct me or add anything you'd like along the way, for sure. Glad to have you.
Sure. I will say for the half acre thing, the half acre question, the trigger for that, the 5,000 square foot trigger won't apply to that. It would just be, you know, a development you know, that creates a full half acre or more.
Great information.
In one, you know, as one new development.
Will the what about the redevelopment standard? Will the redevelopment standard go down to a half an acre of redevelopment?
That's a good question. I don't have the answer to that off the top of my head.
Yeah.
I can look.
Good. We're learning as we go.
Yeah.
Quiz. You have a little residential subdivision with 1/8 of an acre. Adding 0.4 acre of impervious surface, will an operational permit apply? I got one yes. Let's get some answers in that chat box. Yes, yes, yes. That's an easy one, right? The key though is that the permit really only applies to the expansion. However, if the expansion is commingling with the existing site, meaning the runoff there's no way to separate the runoff between the two, then essentially you have to deal with that existing site too. And so that happens a lot in, say, you know, expansion of a parking lot where the grading is consistent across. You're expanding it out. You're not going to be reconfiguring. You don't want to touch the existing parking lot. So therefore now you're dealing with the whole parking lot, and you need to design that system accordingly to manage that extra runoff. So this is really the first pause point here. If anybody has any questions specifically related to when a permit applies, now would be a great time to either type it in, or if you feel comfortable, just unmute and call it out. No questions. There's got to be some question out there. Somebody lob a question.
Dave Marshall here. I'm going to pose a question for Wynn, but I think I already know the answer. But nonetheless, on the 5,000 square feet, basically that was intended in the rules to enable somebody who has been essentially grandfathered to do some minor modifications on the property as far as new impervious surface. But at the same time, it's a cumulative 5,000 square feet. So if somebody built a sidewalk and then removed it, you would still have to count the original sidewalk construction as part of 5,000 square feet when you look at it as of today's date. Is that a fair representation?
Yes. So, right. It'd be any cumulative total, whether or not it was in place or removed, would be counted towards that total. Yeah.
Exactly. Good. Thank you.
Yeah.
And just to follow up on that point, so and basically it's cumulative from that date of July 1st, 05. And once you use it up, then, you know, say you're at a ski area and you've expanded that 5,000 square feet, you know, you've used it up. And so now pretty much anything that you're doing, you're in a permit situation, even if it's smaller than 5,000 square feet, correct?
Correct. Yes. Yep.
Right.
Yeah.
Yeah, and so the question being, in the future, would the 5,000 square foot expansion exemption be over half an acre as opposed to 1 acre? And I think you had mentioned the 5,000 square foot is not going to come into play.
Right. So yeah, if you have something that's just shy of a half an acre, that and an expansion of 5,000 square feet goes in excess of a half an acre, that a permit would not be required in that case.
Pose one more question for Wynn. So it's about 5,000 square feet. So a project that's in place that has 0.8 acres of impervious surface hasn't had any expansion since July 1st, 2005, and now wants to do 4,900 square feet of expansion. Under our previous discussion, that would not require a permit. But as part of the same project that's expanding the impervious area, it does bring them over 1 acre total of impervious on the property. So do they get a free pass on the first 4,999 square feet, and they only have to treat, if they can figure out how to separate it, the remaining amount of impervious that brings you over the 1 acre threshold?
No, the way the manual reads is, whatever the project is that creates the excess impervious, that entire project would need to get a permit. So it's not, you wouldn't have 5,000 square feet to discount, and then you need to handle the rest. It would all come under the permit coverage.
Right. Thank you.
Mm-hmm. The follow-up from Frank question here: would impervious surfaces between half an acre and an acre need to be constructed prior to 7/1/22 to avoid needing a permit once the threshold drops? Seems like maybe.
No, well, so as long as if you remained below an acre, but we're above a half an acre, and the project in and of itself is not a half an acre in total, a permit would not be required.
But in a situation where you have, I'm just thinking where you have an existing site, which is greater than a half an acre,
Mm-hmm.
but less than an acre,
Mm-hmm.
and say, so if it's like 0.6 and you're adding, well, I don't know, I guess it would have to be a situation where you'd be adding, yeah, I don't know about that.
I think maybe a different question would be if you were under an acre or under a half an acre already, and you were going to develop slightly less than a half an acre, but that in total would be over a half an acre, a permit would not be required in that case.
Right. Or if you're under half an acre and you're building, let's say, so if you have a site with like 0.3 acres, you're adding 0.5, so you have a total of 0.8. If that's all done before 7/1/22, then I think you're under your threshold.
Right. Yep. That's correct.
Right.
Yep.
And then the next question, actually, this is good. I'm glad somebody asked this about pervious pavement with respect to how that is treated in the manual. And my understanding, and then I'd like Lynn's too, is that it's, essentially you can, designing pervious pavement appropriately can mean that you have a non-jurisdictional impervious surface, so that will not count towards any of these thresholds, but it does have to be designed and maintained to basically function over time.
Andres, can you touch base on the features that allow it to be considered to be pervious as far as storage and the like?
Right. Well, my understanding is that you essentially by testing with a hydrologic model, you need to basically prove out that the system can have the storage to retain the 1 year, 24-hour storm event. Is that still the case, Wynn?
Yes, that's the standard of what would be treated as a pervious pavement surface. Yes.
So having having at the surface, having a porous pavement surface, and then storage underneath in the stone, which is typically added underneath the porous surface. You need to calculate that you have enough storage there to basically retain that water.
Right. And that needs to be above the groundwater table, and that requirement stays in place.
So when the next question is basically a question of, at what point have you vested your interest before July 1st, 2022, as far as the half-acre rule, with regard to a project that's perhaps been permitted but not constructed? How is DEC handling that breakpoint as far as whether or not you have a project that's been fully recognized as being viable under the old rules?
That's a good question, and I don't have the answer to that off my top of my head on that one either. I would need to look at the permit. Similar to when the 90/50 goes into effect, there's a grace period for specifically transportation projects or projects of that nature that are well under the way of the planning phase.
It's 9 o'clock, bud.
But I don't know in terms of a project that's been planned that will exceed the half-acre threshold, but is built after that date. I would need to look into that.
Gianna's question, can you repeat briefly new development versus expanded? And in the situation that she gives is if you have an existing parking lot and you're going to expand it, cutting down trees, you're going to create this new impervious surface. when calculating the acreage square foot, is it for both lots or the new lot? Well, I think in that situation, assuming that the existing parking lot does not already need a permit for some reason, and the expansion, the new parking lot, that would be the expansion, and that would be the area that would be subject to the new permit. If you're expanding off of that existing parking lot, it would be designated as an expansion, I think, versus a new development. And is it based on parcel boundaries? And this gets into the whole question of common plan of development definition, which is really comes up quite often in residential subdivisions, where you have a common plan of development, which may share an environmental permit, but it may now be separated by different lots. And so the state, in cases where there is a common environmental permit linking a development together, even though it may be now on separate lots, it's still defined as that common plan of development and subject to these expansion thresholds that we've been talking about, this 5,000 square foot expansion threshold, for example. This is where it gets real tricky on some of these situations, to actually go back and figure out, well, is it a common plan of development or is it not? And sometimes those are site-specific type decisions. I don't know, Win, if you have any other input on that, but.
No, I mean, I think you covered it. Typically, when it gets into those situations, it's best to just have a pre-conversation with the district reviewer to get a handle on what is and isn't considered a common plan in a particular case.
So the next question from Joe basically talks about a previously permitted property that wants to expand its impervious surfaces. And my understanding is once you have a permit, you need to amend the permit for any new impervious area. It's pretty much that the only people that can take advantage of the 5,000 square foot exemption are those properties that are currently grandfathered and do not have permits. When is that an accurate representation?
Yeah, that's pretty much the take now. We do allow for some very small expansions that would be almost negligible, but those are pretty rare. We're talking under 400 square feet or something like that.
So those would be waivers that would be provided in direct consultation with DEC
right.
based on the situation.
Right.
All right, well, I appreciate that dialogue, guys. That was, I think there were some good questions that came out of that. There's always good questions on that section. So I think if there's no more questions, we would just move into the next section here about really just starting the foundation of why the manual is set up the way it is. And it's based on this foundation of reducing runoff. And reducing runoff has demonstrated other beneficial impacts to downstream conditions. So reducing stream erosion, reducing flooding, pollution, water quality, and groundwater, making sure that the groundwater reserves are not depleted. So when we talk about runoff reduction, we're talking about reducing the volume. And so not really necessarily just taking care of the peak discharge, but really reducing just the amount of water flow that's running off a site to begin with. So that's a little bit of a shift from where stormwater was in 2002 when the manual came out. It was more focused, I'd say, on detention, and now the new manual is structured to really guide you to maximizing, trying to get rid of that water on site first so you have less runoff moving from the site. Oh, and I forgot habitat degradation as well. So the benefits really of this runoff reduction method are, there's many. There's benefits to municipal and private infrastructure. There's benefits in the long term just in terms of O&M costs, less O&M costs, less water, less maintenance. A lot of these practices which are focused on runoff reduction have some aesthetic value, or at least some benefit, some potential to have an aesthetic value, because a lot of these are plant-based systems, and so there's opportunities to improve aesthetics on sites. And then there's community health and safety, and this is really clear, I think, in more of the downtown green infrastructure, green streets type environment, where you see, and you're starting to see in a lot of areas in Vermont, downtown areas that are being greened. There's a lot of ancillary benefits to that greening, that goes beyond water quality, placemaking, multimodal transportation, sustainability, air quality. So there's definitely a lot of other benefits to this approach that goes beyond just stormwater. And this is an important slide, and this is really the core, I think, of the manual. And you're going to see this treatment volume, this T sub B, quite a bit. And if you open the manual and look through it, that the TV shows up a lot. And that's really that's the amount of water that you're trying to reduce by crediting, designing your site a certain way. We're going to talk about crediting, what that actually means, but also installing BMPs. You're going to be calculating this TV, and then you're going to knock it down by doing either structural practices or non-structural. We'll get into the difference of what those two things are a little later. In the foundation, the way that the manual guides you towards knocking down this TV is through this tiered system. So tiers 1, 2, and 3. So the manual is set up so that you need to first analyze whether or not a tier 1 practice is doable on the site. And if it's not, you go to tier 2. And if you can't do a tier 2, then you're going to go to tier 3. And tier 1 are the best practices. Those are the practices that are, by the current research that we have, those are the practices that really perform the best and reduce the most runoff and reduce the most pollutant loading. And then tier 2, not as good, but pretty good. Tier 3, kind of a worst case. And we're going to go through specifically some examples of each of those so you guys can see what we're talking about. But this is just a graphic here to describe what I had just said. So the TV is the overall volume. And within that volume, we're going to talk about some other volumes that are going to need to be calculated for various sites. You're going to have your water quality volume. You're going to have your recharge volume. You're going to have your hydrologic condition volume in some cases. I say in some cases, we're going to get into that one specifically a little bit, but I'm going to actually go through all these, but that's kind of graphically how it is. So all those are nested within this overall treatment volume. So the core elements of the manual, the unified sizing criteria, we're going to talk about, and that's the specific standards, and I'm going to go through that in this next section. Then we're going to go through the practice selection. We're going to talk about infiltration testing, which I think is a really critical component of the whole process, especially because the whole manual is so focused on infiltration. And so there's some really specific considerations for infiltration testing that should be that people should be aware of. And then reviewing the forms, so making WIN's life easier when the application comes in, making sure everything is organized how DEC likes to see it. Makes things a whole lot easier for everybody. So just starting off on the unified sizing criteria. So the first one, the water quality treatment standard. Water quality treatment standard, we're looking at sediment and phosphorus. We're looking at all the pollutants in the stormwater. And we're looking at managing those small but frequent storms. Groundwater recharge, we're really looking at all storms, but we're looking to maintain groundwater levels. We don't want to pave over, develop a site, and then basically, you know, a nice A site with sandy soil, and then all of a sudden we're paving it, dramatically reducing the amount of infiltration into the groundwater table drops, less base flow in the stream. That's not a good situation. So we're trying to protect that by maintaining groundwater recharge. Channel protection standard, we're talking about managing the 1 year flow. So the flows where the streams are typically bank full. So those are the channel forming flows when we have, they're frequent, relatively frequent, but not too infrequent. So they're important to be able to manage. And we're going to manage that by this channel protection standard. And then the overbank and the extreme flood protection standards, those are really related to the larger storms. So just controlling strictly the peak discharges from those larger storms to make sure that we're not impacting downstream properties from flooding. And the overbank being applicable generally to the smaller sites, and the larger sites where we have, you know, 10 acres or more of impervious surface, we're going to be looking at the extreme flood protection standard, which is managing the 100-year storm. So it's taking a lot of capacity in terms of the volume that we need to manage that storm on site. And then the healthy soil standard, which is a new standard in the manual. This is probably also going to be a good discussion topic point here, because this is a brand new standard, and I think people are just really learning how to not just design and permit, but also follow through on the implementation. So I'll be interested if Wynn has any updates in terms of how people are dealing with that standard. So this is just a graphic here of what I just described. So essentially we have on the x-axis the percentile of runoff producing precipitation events, and then on the y, precipitation depth in inches. So essentially as you go up here, you can see first starting at the bottom, the recharge storms, we're really looking at trying to manage all those storms. We're trying to provide groundwater recharge in all conditions, all different rain events. We want to provide that recharge. And as we go up, we're looking at the water quality storms. We're really focused on up to 1 inch of rainfall in 24 hours. It used to be 0.9 inches in the old manual, 2002. Now it's an inch. And so we're targeting those storms because they're frequent. We get a lot of those, not this year, but typically we do. And so those are really the most consequential in terms of the water quality impacts, because they happen frequently. And when the rain starts, you get the first flush. You get a lot of the pollutants discharged to the stream in these small storms. So our water quality practices are focused down here. As we go up the curve, we talk about the channel forming storms, looking at the 1 year, 24-hour storm event. When you look at what the threshold is at the top of that, you're at about 2 inches. So 2 inches of rainfall in 24 hours. You know, that the hurricane tropical storm that came through a month or so ago, I think was right around there, maybe a little higher. Above that, we get into this overbank. So again, this is the flood standard for the smaller sites. So you can see kind of the top level of that. We're talking right about 3 inches in 24 hours. And then for our largest sites in the purple, right here, talking the extreme flood protection storm. So we're up, you know, over 5 inches of rain. So those are the storms that are not happening very often typically, but they have a potential to do a ton of damage. And so making sure that our site is not releasing a ton of water during those larger storms is the point of this standard. Dave, you have something?
Andres, and that applies for those project sites that have more than 10 acres of impervious area?
More than 10 acres of impervious area. That's correct. And my understanding, Wynn, correct me if I'm wrong, but if you have essentially, if you're talking about this in the context of expanding an existing site, say you have a site that has 5 acres and now it has 10, if it had 10 after, what's the date? 2000. It was after 2002, I believe.
I think that date is the 2002 date, yes.
Right. So if you had a site which in 2003 had 5 acres, and then they've added 5 more since then. I mean, you'd be in a permit situation, but you would also be in a situation where you would need to comply with the 100-year standard because you've expanded out to 10 acres or more since 2002. So now the whole site is subject to the 100-year extreme flood protection standard. Does that make sense, hopefully? Just to dig into this a little more, so talking about the water quality treatment standard, as I was mentioning, it's the 1-inch storm, so it's a 90th percentile storm, 1 inch, 24-hour storm. So that is where the major source of pollutants are originating, including phosphorus, our target pollutant here in Vermont, and also sediment, right? So we have phosphorus, we have algae blooms. All that is a consequence of our managing our small flows. And I mean, in addition to large flows as well, which I'll get into that a little bit. But so in the context of when we talked about the difference between new development or expansions and redevelopment. So that really comes into play with the water quality treatment standard. So in a new situation, you are managing the full water quality volume. So that's 1 inch of rain. But in a redeveloped situation, so where you're redoing a parking lot that's already there, converting it to something else, redevelopment situation, you're only required to treat 50% of the water quality volume, or removing 25% of the existing impervious surfaces, or a combination of the two methods. And so essentially you're getting a break from the full-blown manual requirements when you're in a redevelopment situation. And this is going to come into play tomorrow when we talk about the new 3-acre rule. We have some slides on that, and this is the redevelopment standard is going to apply to those sites. So that's essentially how you're going to view these 3-acre sites, is through this redevelopment standard. So it's 50% of the water quality volume. So looking at the groundwater recharge standard, this has been revised from the 2002 manual. The 2002 manual had the same framework. Essentially, we look at this table down below. We have hydrologic soil group and then a recharge factors. Okay, so the first one that is from 2017, so that's in the current manual. 2002 here is what was in the old manual. And so hydrologic soil groups, I'm sure most of you, if not all of you, are familiar with that, but essentially, if you're not, the hydrologic soil group is a function of how well the stormwater is going to infiltrate. A being the sandy soils that have really high infiltration. D being clay, Virgin's clay, something like that, or till. So in a D situation, your standard, the whole standard's waived because the site is not naturally having any ability to infiltrate stormwater, so you're waived. And these recharge factors are highest for A because in the natural condition, there's a lot of recharge occurring there. And if you're paving that over in a parking lot, that's a really big delta change. And so you need to accommodate for that. And so you can see just between the 17 and the 02, the factors have gone up. So essentially what that means is that you're required to infiltrate more water than you had to in the 2002 manual.
Yeah, just jumping in, this is probably the biggest policy change, as Andres had indicated previously. The intent is that if we can make our sites, the runoff from our proposed developed sites similar or better than what happened under pre-development conditions, then the downstream abutters, the downstream streams, receiving waters, will be experiencing the same thing as undeveloped conditions. So it eliminates a lot of the secondary issues of infrastructure and erosion of our streams and the water quality issues that ultimately go with larger peak flows or more regular large flows off of these developed lots. So the ability to basically manage your stormwater on site in a manner that basically gets it back into the groundwater regime is really the ideal situation with regard to, again, eliminating those secondary issues.
So for the groundwater recharge standard, as I was saying, there's a waiver for if you have a D-soil where there's no natural infiltration capability there. It's also waived for other situations. And so it's waived for a situation where you have a stormwater hotspot. And so some examples of stormwater hotspots: petroleum distribution centers, hazardous material loading and storage facilities, or if there's subsurface contamination from prior land use. And in some cases, infiltrating stormwater into that site is going to be problematic in terms of managing a plume of subsurface contamination. And that one, I would say, is pretty important, but not always obvious. And that really, I think, takes some due diligence in terms of looking on the A&R Atlas, looking at the surrounding area in terms of, maybe not even on your site, but it could be potentially off-site, where you have a situation where there isn't a plume and there could potentially be some impacts to it from groundwater recharge. And so, if you're just looking at your site, that might not always be obvious. But in situations where you have a hotspot land use or some issue with subsurface contamination, stormwater shall not be treated with structural or non-structural STPs that rely on infiltration. So talking about a line structure, we'll get into what that means, line, with a collection system underneath, so essentially operating as a filter versus an infiltration structure. Anything else, Win, on groundwater recharge waivers that you've seen? Any other special circumstances on that?
One thing that has come up recently, or something that people may not be as aware of, is looking at the groundwater protection rules for what would be considered hotspots or sites that are specifically not allowed to infiltrate. One of those being salt storage areas, which has come up recently. And then the other thing you already touched on, which is really important, is that the contamination may not even be on the site. It could be surrounding properties.
So within those groundwater protection rules, there's some specific requirements which would then move the stormwater. It would apply to that practice.
Right. Right.
So moving from groundwater recharge, we were talking about the channel protection standard, the overbank flood protection standard, and then the extreme flood protection standard. And all those require a analysis of rainfall event criteria. So what are the recurrence interval depths for these rainfalls? And so that is obtained through this NOAA Atlas 14 website here. And there's a range, depending on where you are in Vermont, it's definitely going to be site specific. And so this is where you can obtain that data, understanding, the 1 year storm, 24-hour storm, is it 2.1 inches or is it 2.3? Or is the 100 year, 5, or is it 5.4? So this is where you're going to be able to get that site specific information. So the channel protection standard, the new manual allows a little more flexibility in terms of how you can go about meeting this standard. And one of the ways, there's 3 different ways, and I think the new one that we'll talk about first is this hydrologic condition method. In the manual, you'll see this as HCM. So that's really this runoff reduction focused approach. And so I'm going to get into what exactly that means on a few slides, but essentially that means just reducing, we talk about reducing the volume, the framework of the manual. This is specific to reducing the volume of the 1-year storm coming off your site, and you can claim compliance with that standard by knocking that volume down. The second way is the extended detention method. So for those that have been working in the 2002 manual, same idea. So having a big area, a pond, draining it through a small hole. So really metering out that 1-year storm over a long period of time to eliminate this peak into the stream, which has impacts to the banks because the stream is running high and it's running long and it's weakening the banks, and you get in-stream erosion and instability. So that's really what we're trying to prevent. And then the third thing is this alternative extended detention method, which I'm going to get into specifics as well. So on the first approach, the HCM, in the graphic here, you can see really what we're trying to do, right? So we're generating a high runoff volume, and we're knocking down that volume. And that change in between pre-development and post-development is this HCV. So that's really what we're trying to control and trying to manage through on-site management. And essentially what we're trying to do is approximate the runoff characteristics of woods in good condition for the 1-year 24-hour storm event. So if you have a development site, we're trying to replicate the hydrology conditions of a pre-development site, which is a woods in good condition. Good condition means ground cover is pretty covered. It's not bare. It doesn't have roads through it. It's generally has good ground cover, and it's a good forested condition. That's kind of how it's described in the NRCS. So the second extended detention method, so this is the one that's been around since the 2002 manual. Here's our pond. This is our outlet. Imagine you have a small hole on the end of this pipe, collecting out all that water and just bleeding it out that small orifice. That's the extended detention method. And then the third method, which is this alternative extended detention method, if we have peak discharge from the site, it's essentially the same with 1-year detention and 1-year disconnection. So this gets into a little bit, I realize this might be kind of complicated and confusing. It's a little bit of a theoretical exercise, but if you have a developed site, and say you, through hydrologic model, you would have a theoretical basin that's going to provide that channel protection detention. And then you have a proposed condition where you just have that water dispersed and diffused. And if you can demonstrate that the peak discharge is the same in those two conditions, then it should be acceptable just to go with the condition of where it's diffused, because essentially the diffusion is doing the work that putting in this basin would be doing. That's what you're proving out, that, hey, same thing. We're getting that benefit by just diffusing the site. And so that could be a good tool if you have a site where you're really trying to diffuse the water, not really collect it all in one location, potentially save on cost by doing some lower tech solutions. That could be a good option to explore. So within the channel protection standard, there are a couple waivers. There's one waiver which is no longer available. So the waivers that are available, if you're pre-routed, post-development discharge from the site is less than 2 CFS. So what does pre-routed mean? And how do you calculate that? So pre-routed means if you have a development site that you're analyzing, you're not going to be able to say, look, I'm going to send it through this little pit here, and then there's going to be some detention that's going to occur in there. So then when the water comes out of that pit and it's left the site, our discharge is going down below 2 CFS. Essentially, what the state wants to see is that your footprint as is with the soils that are around it, as the runoff is going to be dispersing off the site, you're going to have less than 2 cubic feet per second of a peak discharge. And that's going to have to be proven out using a hydrologic model. And we're going to, we do have some slides on HydroCAD tomorrow as part of the exercise, which is definitely the most common hydrological model. And you would need to demonstrate that by modeling that you would achieve that condition to get that waiver. The second opportunity for channel protection waiver would be where you have a direct discharge to waters with a drainage area of greater than 10 square miles. So think, a site where you're directly discharging to the Winooski River or the Lamoille River, large rivers, really 10 square miles. And I think it's really important to highlight direct discharge, because I think this gets to be definitely a gray area in some situations where somebody may say, oh, I have a site and it drains to this little swale, and that little swale goes through a culvert, and then it goes to the river. So question being, is that swale actually a stream, in which case you're not discharging directly to the Winooski, or is it in fact a swale and you are discharging to the Winooski directly? So I was going to ask you on this, if you have any, to that point, if there's anything else you can think of that would be useful for people to understand in terms of what a direct discharge is.
Yeah, I mean, I think you hit it there with, it has to truly be a direct discharge, either via a pipe or a clearly defined man-made channel that's stable, as opposed to what may be an intermittent stream, or especially, pretty clearly not any sort of small tributary would not be a direct discharge.
I think Wynn just raised an important point, which in hindsight, I could have included some slides on this, because I feel like it is a really important issue. But what is a stream? What is your discharge point when you're analyzing a site? Is it a man-made conveyance, or is it a stream? And in a lot of cases, I would say most all cases, it's a stream versus a ditch. I mean, a lot of times you have a historic drainage way which has been manipulated over time, so it may look like a ditch, but if it's carrying waters of the state, my understanding is it's still a receiving water, and you have to treat it like a receiving water, meaning you can't just dump untreated stormwater into it and then recollect that area. So it's definitely a site-specific kind of a determination, but it's important to just be aware of. It's not always clear what your actual discharge point is, and so I would encourage you to bring that up with the reviewer if there's any questions about that. Dave, jump in on that if you have any question or anything to add. If not, I'll continue.
No, I think stable means of conveyance is critical, and I think that's been, at least in urban areas, probably one of the biggest challenges of determining whether or not you are dealing with an old stream that's been manipulated by man over time, or whether this is truly just a man-made conveyance that basically gets the drops of water from one point to the other. So we're always looking to demonstrate stable means of conveyance to ultimately this large receiving water that has a drainage area of greater than 10 square miles, and that's really the key on the one side of things, complicated by the issue that you brought up. Good.
So with the overbank flood protection standard, we have on the left, this is your undeveloped site, and then on the right is your development. So following the 10-year, 24-hour storm, peak discharge is equivalent between the undeveloped and developed sites, or preferably even less. But again, this is something that's borne out with hydrological modeling, understanding what your peak discharge is in the existing condition on the site that you're starting with versus post-development. Making sure to match, bring down that peak discharge for the 10-year after development. So the waivers, some similar stuff here with the overbank waivers. So essentially, direct discharge to waters with a drainage area greater than or equal to 10 square miles. And again, I think Dave's point to stable conveyance is important here. I mean, obviously, it's not a good idea to, if you have a site and you're discharging, you want to make sure that that water is arriving to the receiving water without causing more problems in terms of erosion, blowing out downstream infrastructure, et cetera. So that's definitely something to consider if you're claiming that waiver. So the downstream analysis is completed that indicates overbank flood control is not necessary for this site. So this is, I don't plan on getting into the specifics of the downstream analysis, but it's definitely an important concept to understand. And it's an important tool sometimes to be able to utilize. The downstream analysis, what it essentially does is allow you to have an increase in a 10-year discharge after development if you can prove out through modeling that downstream of the site you are not going to have impacts to infrastructure or other sites. And so, because in a lot of cases, depending on the watershed characteristics, say if you have a small increase in your 10-year discharge, if you're in a large watershed, that increase may not show up at all when you start moving downstream. There may not really be any impact from that increase. And so the state allows you to get a little break on that if you can demonstrate that there is no impact. And there's a really specific process that's in the manual to go through the steps to do the downstream analysis, and it requires modeling the contributing watershed area, so not just your site, but also all the water that your site is draining to, so that you have a full picture of the existing and the proposed peak flows, not just from your site, but also, assuming all the water that's coming down in the watershed as well. And then analyzing any structures, culverts, bridges, stuff like that, which may be in the way downstream, and understanding if there's any impacts to those structures. And the downstream analysis was more simplified in the 2002 manual. It's definitely gotten more specific in the 17 manual. And so there's a page or two on it in the manual which really describes exactly what the process is that you can go through and look at. And then new from the 2002 manual, the pre-routed, again, pre-routed meaning this is your development site. You're not including any routing through any kind of structures that you might have, but just as is, pre-routed. Post-development, after development, the discharge from the site is less than 2 CFS. So this is really just reserved to those really small sites where you would say, look, in the 10-year storm, it rains 3.5 inches. It's not even generating 2 cubic feet per second. It's insignificant. We're not going to worry about it. So then the extreme flood protection standard, as we talked about getting into the sites where you have 10 or more acres of impervious surface. So these are the big shopping centers, campuses, college campuses, the largest kind of development sites in Vermont are subject to the extreme flood protection standard. So just like the 10-year, following a 20, but really just looking at the 100-year, which is 5 inches plus of rain, peak discharge is equivalent between the undeveloped and developed sites. Preferably less, right? Preferably we're designing things which are actually even going to reduce that peak discharge. So with the waivers that are allowable, same one with the 10 square miles, we talked about that with the channel protection, and then also the overbank flood protection standard, same waiver applies. And then talking about if the impervious area on site or otherwise associated within a common plan of development, should say development, constructed after 2002 is less than 10 acres. So remember we talked about that, where you draw that line. So there is a way but essentially, if you're in a situation where you've developed more than 10 acres after 2002, you're going to be in a situation where you need to meet the 100-year standard.
Yeah,
And then
I'm sorry, I'm just being rude. Just going back to the statement or the term common plan of development, that can bring in a lot of properties that perhaps a client or an applicant does not control. So one of the rules of thumb that we've been advised to use is, for example, if your property is subject to Act 250, then all of the other properties that may be a component of that common plan of development, whether it be a subdivision, planned unit development, all of those impervious areas associated with that particular originating Act 250 permit should be considered as the total impervious area for this particular analysis. So help out if there's been additional clarification or supplement on that guidance.
Yeah, I mean, it's really, like you said, projects that have a shared permit, whether that be a wastewater permit, Act 250 permit, that were sort of all developed under a common plan, that were all developed as one big project that may have multiple owners. In addition to that, I should add, a subdivided property typically is brought under that, even if it's maybe constructed or developed by multiple parties.
Okay, that's great. Some of you might recognize this picture. This was Irene, I think Route 4 going up towards Killington. I think this is about 8 inches, right, in this area. I guess this is in Mendon. So a very substantial storm. 8 inches plus, our overbank, our extreme flood protection standard. Hopefully, if things were engineered properly, the water could just get through, but at that point, all bets are off. Everything is overflowing. So then after the 100-year standard, talking about the post-construction soil depth and quality standards. So this is a new standard in the manual. And Dave, you can run through this if you'd like, or I can, either way.
Yeah, we'll kind of tag team this one. This is as Anders points out, a new component, and this is one that we're wrestling with contractors to implement as part of the construction phase. Specifically, the goal is to restore the soil profile in a manner that is representative of what the pre-development conditions were. So one thing that we've historically seen if you can imagine a building being put in place and you have all sorts of construction equipment around the outside of it, you probably have had the contractor strip the topsoil and stockpile it off the side, but underneath that top 4 inches of topsoil that's been stripped off is the substrate, and that just has historically been compacted significantly only because of all the lifts, all the other construction equipment accessing the perimeter of the site, to the point where when there is a series of storm events that otherwise could be stored in the soil profile, vertical profile of the soil, it might be stored in the top 4 inches, but everything underneath is so compacted that it doesn't infiltrate in. And we now essentially have more runoff than what we had from a modeling standpoint of pre-development conditions. So the new rules put in place in 2017 require that we work harder towards restoring that top 8 inches of disturbed areas on a construction site. And in this particular case, the top 4 inches, well, I'm getting ahead of myself, but one of the more important components is that the top 4 inches does have a organic component. And this actually may be better than what your native soils already have out there. And some people scratch their head and say, gee, why are we making it better? Well, this is just one of the tools that's been put into place to make sure that we are also trying to create a vigorous growing environment. So vegetation can also improve some of the characteristics of runoff in this area. So soils that don't have 4% organic matter sometimes will be thinner in girth than something that has a healthy environment to grow in. So that's one of the things we'll touch base later on in the slides here in regards to what we need to be doing in order to basically make these particular soils better. However, there are also exemptions or waivers in regards to how to apply this particular standard. And the first one is slopes that are greater than 33% or 1 on 3. Under pre-development, post-development conditions, those steeper slopes really aren't contributing significantly into the infiltration component, just because the drops of water hit the top and they kind of want to go sideways rather than straight down. Obviously, impervious surfaces, we're not going to be putting topsoil on those. Structural STPs, again, anything that is a component of your stormwater management system doesn't have to also have this particular 8 inches of fluffy material on the top. And then lastly, engineer soils as structural fill. There are situations where we design over steepened slopes or certain functions on the site that rely upon very stable soils and not loose soils to provide the structural integrity from a stability standpoint. And those particular features or components of a site are also exempted. So if we can go to the next slide, we can talk a little bit about exactly how this occurs. And one option simply is to don't mess around with the existing topsoil. So if you can create a situation where you make a physical improvement adjacent to undisturbed area, and you can basically protect that undisturbed area from anybody driving by a mistake or otherwise on top of it and creating compaction, then you basically get a free pass in regards to having to modify that. But in those particular areas where we are stripping topsoil and looking to replace it, we need to, in the top 4 inches, as you can see on the right side of this screen, we need to basically make sure that those particular soils that are going back do have the 4% organic component. And if you're fortunate that the native soil already has it, then you're good to go. If it doesn't, then you need to be adding some soil amendments, most often some form of compost, to beef up that particular organic content. So again, the ability to understand this ahead of time is so important to basically make sure that your specifications and design plans and permit plans are properly reflecting where you're coming from and where you need to go. So especially for the contractors, because soil testing will help you, well, it will tell you what you've got for that organic content. And more importantly, it'll allow your contractor to understand just how much amendment he's going to need, he or she, will need to put into place in order to comply with the requirement. So what we're finding, I'm going to kind of jump ahead. No, I guess I've kind of touched base on these ones. Andres, if we can go to the next slide. Nope. All right, I'm going to go back and talk a little bit more about this. So this is what we're finding in the field actually happens, is that the contractor can remove the top 4 inches of topsoil, amend it, and put it back. But before you're allowed to put it back, you have to modify the 4 inches below. So you're ending up with a total of 8 inches of, well, we use the word fluffy, very technical term, of soil. And in this particular case, you can go in and rototill, the second 4 inches underneath the topsoil before you place it to prep this. So loosen it up. After all the construction equipment's done, you come in and you rototill it. Now, most contractors just don't feel that that's an efficient use of their time and resources. So what they're doing is over excavating 8 inches. And now they have the question of, how do they manage putting the soil back in place. And some contractors are simply saying, it's not worth me trying to put in 4 inches of substrate and then 4 inches of topsoil. I'm just going to put back in 8 inches of topsoil. And for some sites that have a large amount of new impervious area where they now have displaced not only, the 4 inches of topsoil and only need half as much to go back, they have essentially topsoil that can fill the full 8-inch profile. But again, the other side of the coin is that they're also going to need to modify that to make sure that it's got the 4% organic content in the top 4 inches. So it really is very site specific and very contractor specific as far as how to achieve the 2 components, which is organic content in the topsoil and top 4 inches and a loosened component beneath it. So every project needs to make this clear to the contractor, and we have many discussions with ultimately the contractors on how to execute that. And every site, again, depending on its characteristics, will send you in one direction or the other. But it is something that, again, the intent is to basically create the ability for drops of water to infiltrate the surface and to essentially replicate what Mother Nature does on a regular basis through freeze-thaw cycles that loosen up the topsoil, top 8 inches, or through root growth and die-off. It's creating these void spaces that allow drops of water to, again, be contained within this particular profile area. And our job is to basically try to replicate it to the best of our ability.
Thanks, Dave. That was this is a really this is an important conversation here, I think, because this is a new standard, and there's definitely, I think, some questions out there in terms of how this gets translated from the planning and permitting phase to the implementation phase to the long-term operation and maintenance phase. It kind of raises a whole host of questions about how really that process works, because it requires communication between kind of a chain of different people that has to happen for it to be successful. Meaning, we have the designers and the engineers, putting in the applications, the state reviews it, and then, the project gets permitted, it gets built. And so that information, this information needs to be communicated to the landscapers who are actually installing it. And then it needs to be communicated to whoever is going to be owning the permit in the future, that this needs to be kind of kept in place for perpetuity. And that, there isn't a situation where people are bringing in other fill and kind of compacting it in the future. And it raises, I think, a whole host of questions about, geez, well, this was, it was the contractor says, geez, it was 4% when I bought it and I hauled it over here, and now this has been sitting on site waiting to go in, and now it's less than 4%. Well, that's not my fault. When I bought it, it was 4%, or even when I bought it, it was 4%, and then now it's gone in and it's been reconfirmed after it's gone in, and geez, now it's only 3%. So then what happens? And so there's a whole host of questions like that, I think, that could come up, and I would be interested to know, from the state's perspective, if they've seen any of these issues that have cropped up or had any discussions with people specifically about this standard. Is that anything that you've been dealing with, Win, to date yet, or no?
Yeah, the few projects that have been completed that were permitted with this standard in place, the question has come up specifically, how is this certified, and whose responsibility is that? We've primarily relied on the engineers, the initial statement of compliance to be the certification that this standard was put in place upon construction. It seems to be that typically the topsoil is stockpiled, and then there's the pre-approved rate that seems to be used most commonly, just because there's no calculating or soil testing required for that to use that standard. I think if someone were to buy topsoil and put it on site, and they had a testing results on hand, and somebody went back later and found that there was a decrease in the organic content over time, I think we would still understand that at the time it was purchased and placed, that it was done at the appropriate standard. With the goal being that there is this vigorous vegetative growth taking place, and the soil used allows for water infiltration and water storage, and ideally as well, less fertilizer would be used as part of the goal as well.
So one thing I also wanted to mention as far as the certification end of things is that the manual recommends a pretty strenuous investigation post-construction on this particular area, and the slide shows a spade going into the ground. One of the requirements is that there be 9 investigation sites per acre, where you go out with your shovel and you're going to basically shovel down to get a understanding of what the profile looks like, and more importantly feels like, when it comes to excavating these particular areas. So these are all components that are intended to enable post-construction certification as part of this particular process that Wynn mentioned. And when you do the math on 9 sites per acre, that's basically every 70 by 70 plot needs to have one of these investigation sites. So it's fairly rigorous in regards to ensuring that the quality, as part of the quality control for the project.
Yeah, and we're going to get into some more specifics at a later time in terms of what the state needs to see on this, what's called post-construction soil plan. So Dave just alluded to that. There's some specific requirements in terms of indicating to DEC where on-site verification would be done, and how many holes are going to be cored to be able to evaluate this standard. So I had noticed in the chat there's some really good information that people should pay attention to from the state, from Hugo here. We were talking about contamination, potential impacts to contamination, and one of the pieces of information here is that the sites management section has guidance on conducting subsurface work within the right-of-way that is very nearly in final version. And then confirming the A&R Atlas is definitely a great tool. So we were talking about looking at, potential hazardous waste sites around in proximity to our site.
Andres, can I say something?
Please.
Yeah, I've done a lot of projects in hazardous waste for like 35 years, and there is growing work of stormwater management in the urban centers. And so the problem is that it's not just only the sites that are listed, but there are historic conditions that have not yet been found. And if someone doing a stormwater project inadvertently digs into that and mobilizes the water or extracts soil and transfers it somewhere, they need to understand that there will be liabilities post that work, because if somebody subsequently finds this is contaminated, that dirt needed to be handled in a different way. And likewise, if we do a stormwater project like I've done some in downtown Burlington, the proposed basin had to be a non-infiltrating lined retention pond, because had they gone with the original infiltration approach, they were going to mobilize groundwater contamination that at the time the designer was not aware of. So there are kind of hidden liabilities for the people that are doing the stormwater installations. Then I followed up with a link. So if you guys want the link to the current guidance, sites management is just kind of adapting the guidance for utility work until the final is approved. And I was one of the co-authors on that final, but we don't have all the approval to issue it yet, but it will be coming very soon. So thank you, Andres.
Nice. That's excellent. Thank you for that information. I really appreciate that. So one of the other questions here that's come up from Lynette on the direct discharge, we talked about the direct discharge waiver. So this is specific to the 3-acre parcels. So this is, we're going to talk about this tomorrow, but with the general permit 9050, we're going to be looking at the state retroactively requiring permitting and stormwater controls for impervious surfaces which have 3 acres or more impervious area on site presently. And so when we talk about a 3-acre parcel, I think that's what Lynette's referring to. So question, direct discharge waiver covering the 3-acre parcels that needed treatment, how many are direct discharges? So I guess for the first part of that, the 3-acre rule, we're going to be talking about how to apply management to the 3-acre parcels, but it's strictly going to be looking at the water quality volume, and in some cases the 1-year channel protection volume, but not necessarily large storm control related to the 10 or 100 year. And so the question might be specific to the channel protection volume. And I'm not quite sure if there would be a waiver in a case where if the channel protection volume is required as part of one of these 3-acre sites, could you actually demonstrate that you're discharging to a watershed 10 square miles or more and actually get that waiver? Not entirely sure about that. When?
So the direct discharge waiver, like you said, it only applies to the detention standard, to the channel protection standard, and the 10-year. And so under the 3-acre requirements, that wouldn't be part of what is needed if the receiving water is a lake or a larger river. The only time channel protection is going to be required under the 3-acre requirement is in stormwater impaired streams.
In which case, and I don't think any of the stormwater impaired streams are greater than 10 square miles. I could be wrong about that, but
yeah, I don't believe so.
In terms of the second part of that question, I don't know how many direct discharges there are out of those 3-acre sites. I think there's 700 plus properties right now that have been identified right in the Lake Champlain Basin. I'm not sure if anybody's analyzed if they are, how many have this so-called direct discharge to a large water body. I'm not really sure.
Yeah, I don't know that either off the top of my head.
So one of the other questions here, so this is a question again related to the 3-acre sites, subject to the redevelopment standard, where there is no new development. Is the 50% water quality volume / 25% impervious reduction criteria the primary design standard for addressing compliance with the existing site? Yes, it is. That is the standard. And do recharge and channel protection standards apply? So as Wynn was just saying, the channel protection standard only applies in stormwater impaired watersheds. So most of the sites, no, you're not dealing with channel protection, and also not dealing with recharge, I don't believe either. You're dealing with recharge, but not well, I guess you're not. I think you're really just focused on the water quality volume.
Yeah, that's correct. Recharge is not part of that.
So then David's question for the soil standard, what is the area to which it applies? If it has a larger site, but construction activity will be confined to only one portion, does it apply even in areas unaffected by the project? I don't believe, I think it's disturbed site areas other than the waiver areas that David had mentioned related to steep areas or in the bottom of a stormwater feature. But the only other areas that it would be applied is where you're actually reworking the site, not necessarily part of another part of an existing site. And so related, good timely question, do we have any breaks planned into the schedule? Yes, we do. And I think that now would be a good time to take a break. We were budgeting 15 minutes. So, you know, if 10:06, I mean, why don't we start back up? Do we want to start back up at 10:22 promptly? Give a little time to go hit the bathroom. And then we'll start back up, and then we're going to spend the last hour going through some more details and leaving a little bit of time at the end just for a follow-up discussion before we call it quits for the day. So if that sounds good to you all, we'll just plug back in and I'll start back up. I'm just going to stay on here and we'll start back up in, at, let's say 10:23, get an extra minute. All right, hopefully everybody's back from their break. We're gonna get going here in a minute. So I'm thinking we have about an hour, maybe a little bit longer if we have a chat at the end, which would be good, and we can just talk about the plan for tomorrow. But I'm thinking right around 11:30 or a little after that. All right, so we'll get right into it here. One thing, just as a reminder for those that were in late, if you are in need of professional development hours, you should put that in the chat. Christine will will record that, and you can get your credit for being here. All right. So we're going to talk about, we just went through the unified sizing criteria, right? So the water quality, recharge, channel protection, overbank flood, extreme flood, new soil standard. Now we're just going to run through the actual practices, so the STPs that can be used to meet these various standards. So first, we're going to talk about pretreatment. So essentially, with the practices, there's, well, I should back up. There's structural and non-structural. First, we're talking structural, and so within the structures, there's the pretreatment element, and then there's the main treatment or the primary treatment element. So we're going to talk about the pretreatment first. Pretreatment is required for practices to maintain the ability for the structure to work over time. You know, it's intended to basically catch sediment, debris, that kind of thing before that material makes its way into the main system, which is going to follow it up over time, require more maintenance. So it's just an overall operation and maintenance benefit. And so there's some specific things that are required from the pretreatment standpoint. So this is really probably one of the most common elements here that people have probably seen. So like a forebay, right? So an area where the stormwater comes in and collects the sediment and debris before it overflows into the main system. So that's a photo here of this rock area. We also have the option to do these proprietary systems. So this is an example of I think this is actually from Hydro's Downstream Defender site, or their first defense. It's a tank essentially designed to swirl the water and the sediment drops out from beneath. So this can take the place of a forebay, which is just, you know, this open pit essentially. So this could be a nice way to save space. It can also be a way to save on aesthetics. Sometimes forebays aren't the nicest looking things. This also gets into a question of alternative treatment practices. I'm not sure if Wynn is back on yet, but he could probably speak to this in terms of, yeah, he is here. In terms of how the DEC is dealing with all these new systems which are coming out all the time. And some of them are great, but there has to be some way to make sure that they work and make sure that they're meeting the standards. And so the state now has a process for basically reviewing and approving these alternative treatment practices. Wynn, would you mind just saying a word or two on that?
Yeah, so there's a proprietary practice section in the manual, and it lays out what's required. For the most part, it's a third-party field testing has to have been done. And based on that, you know, if it's a pre-treatment practice, we would need to see that it removes 50% of the total suspended solids. And if it were a treatment practice, we would base it on our tiering protocol of our manual practices based on the removal rates of phosphorus and total suspended solids. So tier 1 being 98% TSS and 80% phosphorus, and then it goes down from there. Those protocols are laid out in the manual. There's like a Washington Department of Environmental Protection has a very specific protocol that a lot of other third parties use to sort of set up their testing, and there's a few other ones.
I think you guys have a specific web page in the stormwater program site, right? That actually highlights the structures which are approved.
There is, yeah. I can put that link in the chat right now.
Great. Thanks, Wynn. Another pretreatment structure here, swale. Swales used to be primary treatment. They're no longer approved for primary, so they're just now pretreatment type structures. So, you know, in lieu of a forebay, you can have a swale. And this is kind of a busy slide, but this just lays out it kind of gives you an example of some of the things in the manual in terms of the criteria for being able to demonstrate that you have a structure which is going to qualify as a pretreatment structure. So in terms of the swale, you have to demonstrate that you have a 5-minute residence time of the water quality storm peak discharge. So what does that mean? First of all, how do you prove that out? So easiest way is through modeling again. So modeling the 1-inch 24-hour storm, which is the water quality event, modeling that flow through your swale, and then looking at your modeling results and seeing the detention time within the swale, making sure that that water is going to be sitting in the swale for at least 5 minutes as it travels through the swale on average. And that's an assurance that there's going to be enough time to have the sediment and materials dropping out into that pretreatment swale before it goes into the main structure. The manual also has an allowance for a filter strip as being a pretreatment structure. And this table in here, I think, was inadvertently left out of the manual. I'm not exactly sure that it hasn't been replaced with an updated version. I don't believe it has, but there was a table that was originally left out of the manual by mistake, and it was related to the parameters here, which describes how long your filter strip needs to be and the slope of the filter strip. So when we say filter strip, what do we mean? Essentially just a grassed strip off of, say, an edge of a parking lot where the water can flow, a sheet flow over that area and get the pretreatment necessary before it goes into something like a bioretention area. So depending on the amount of impervious surface draining over that filter strip, and also depending on the slopes that you have, there are some minimum lengths. So 35 feet of impervious surface, between 10 and 15 feet of strip, depending on the slope, up to 75 feet of impervious surface, between 20 and 25 feet. So the most common pretreatment structure is really the forebay, I'm sure. And the forebay is designed to be sized based on 10% of the water quality volume. So if you have a water quality volume, which is like, 5,000 cubic feet, you're going to be looking at a minimum of 500 cubic feet of volume in your forebay. And the volume, also the sediment forebay has some constraints in terms of how deep it needs to be. It needs to be a minimum of 3 feet deep. The volume kind of goes up as it's minimum of 10%, say if you have a gravel wetland. But if you have a filter, say a sand filter or something like that, or for an infiltration structure, say like an infiltration basin, the volume of your forebay is going to go up. And the reason is because those structures, I think, are more prone to clogging over time and then failure. So the state wants to make sure that we have a lot of pretreatment in those particular, for those particular structures. One of the nice new additions to the manual is this deep sump catch basin option. So looking at, the sump being that area of the catch basin below the pipe. So just the area which is going to be filled in water. And in order for the deep sump to be an approved pretreatment structure, you need to have 4 feet minimum depth or 4 times the diameter of the outflow pipe. And there's some other requirements in terms of limiting the amount of area that's draining into that deep sump catch basin. So it has to be a pretty limited area. But if you can meet that limited area standard, it's actually really nice. It's a nice structure to take advantage of. And then I was saying the proprietary devices, which Wynn had explained about minimum 50% TSS removal for water quality maximum flow. And that's proven out by, the research testing sites that Wynn had mentioned, some of the national testing sites that are out there. And so the structural practices, so now moving from the pretreatment to the primary treatment structures, we're talking bioretention, okay, dry swales, infiltration basins and chambers. So these are underground. Talked about permeable pavement. So, getting back to an earlier question, permeable pavement is a way to get out of a permit to begin with, but it's also a way to, if you're in a permit situation, to manage your stormwater. Filtering system, so sand filter. Treatment wetlands. Gravel wetlands in particular, I think, have become much more popular. There's a ton of them being constructed now, where normally people would have been constructing wet ponds. They're constructing gravel wetlands. So that's a very popular practice. And the wet ponds, dry ponds are still around. We were talking about the tiers. And a wet pond is a tier 3 practice. So you really have to show that your site needs to have a wet pond in order for it to be approved. And actually, Wynn might confirm this for me, but I think that in one case where you would see a wet pond most often is if you had an existing site that has an existing wet pond and you're expanding out the site and you're in need to somehow modify that existing wet pond. The state is not necessarily going to make you convert that wet pond to a higher performing structure. I think the fact that it's there to begin with could be justification that you could essentially just expand it out and stick with that current BMP. Is that still the line of thinking, Wynn?
Yeah, that's generally the way it's viewed. You know, we typically would look for maybe a higher tiered water quality practice if there's space available on site, and then allow for relying on the pond for the detention standards. But it could be that the pond is what's used for the water quality treatment as well.
If there was sufficient justification that, you know, there was no other option to install another higher tier practice.
Right.
Right. Green roofs, you know, not super popular. I'm not sure when. Have you ever even seen one of these come across your desk? Maybe at the airport or something. But not many.
Not many, no.
Rainwater harvesting, becoming definitely more popular. So capturing that water, reusing that water as gray water on site is an option now in the manual. Alternative systems, we talked about these in the pre-treatment section. So there are also some primary treatment approvals that the DEC has that can be functional for standalone compliance. And I think actually the jellyfish is one of them. They're not cheap. They're compact for sure. They're, you know, and they can be put underground. They're great in a retrofit situation. But, you know, they require maintenance of the cartridges over time. So there's some pretty significant maintenance costs. So like anything, there's no, you know, silver bullet. They definitely have a great place, but the proprietary stuff, a lot of it is expensive over time, and sometimes requires specialized equipment that, you know, a smaller municipality might not have access to. So it's just something to consider. But I think more and more, it seems like the state is approving these alternative treatment practices. So there's just more tools in the toolbox, I guess. So we talked about the structural stuff. So the non-structural practices, I think the manual is more focused on non-structural. So diffusion, dispersion, just passively treating stormwater as it drains the site. You know, when we talk about non-structural things, we talk about simple disconnection or disconnection to filter strips and vegetated buffers or reforestation. These are really the key non-structural practices. So when we talk about simple disconnection, what does that mean? Essentially what we're doing is taking runoff from an impervious surface and dispersing it over a pervious surface in a way that it's going to get some treatment by slowing the velocity, dropping materials out, potentially getting some infiltration. So up on the top here, this is a schematic of a roof. You know, simple disconnection is used a lot for just rooftops. So where you have the downspout coming down, you have a pad, you have a concentrated inflow energy dissipator right here. So some kind of a structure to basically spread that water out over the grass. And then you have your grass or native vegetation here. And you have a certain length right here of your receiving area. And what that is that's where the treatment's occurring. So that is going to be dictated by, again, the soil conditions. So where we have a good soil, an A or a B soil, or an infiltration rate of greater than or equal to 0.5 inches per hour, we're looking at a disconnection area of 35 feet if it's gently sloped, or 50 feet if it's up to 15%. And as we go down to the soils which are not going to infiltrate as well, the lengths get longer. So you're going to need more disconnection area to provide that same level of treatment. So that's why we have the longer lengths. So that was simple disconnection. The disconnection to filter strips and vegetated buffers. Really the same concept. Essentially just taking water from an impervious surface and diffusing it over a pervious surface. In the case of a vegetated buffer, we're really talking about more of a planted, not necessarily a grass area, but like a planted area. And we have the same requirements here for the disconnection area and the slope requirements, same kind of thing. And then the final non-structural practice is reforestation. So this is new as well. This was not available in the prior manual. And really there's three types of reforestation: active reforestation, passive, and then the single tree credit. And you can see the description and basically the credit that you're getting. And I have to say, it's not much. So maybe in the future, if there could be some justification to back it up, you could get more benefit, more credit, which would then, encourage people to utilize this credit more often, because I don't think it actually ends up being much in terms of, the overall volume. But it's something. And if you're doing it anyway, you might as well take credit for it, or it could be that motivation to do it, right? So this is, touched on this before, right? This tiered protocol, tier 1, 2, and 3. And now I'm just going to go through it in a little more detail. And it's really, as Wynn was saying, it's organized by pollutant removal efficiencies and runoff reduction potential. So we have groupings of STPs based on how well they perform, and for pollutant removal and also runoff reduction. And by that, by their performance, they are classified as tier 1, 2, or 3, and you need to use a tier 1 unless you can justify otherwise, down to tier 2, and then ultimately down to tier 3, which is fairly, not as common.
Andre, just jumping in, there was a question earlier about how this is set up. So this is a good summary in regards to how the rules have been laid out in regards to the use of tier 1, 2, and 3. Obviously, the preferred one is our tier 1, and then if you can't do tier 1, you go to tier 2, and then of course work your way down. And the question came up is, hey, are these arranged based on engineering efficiency or cost per square foot? And the answer is really no. I think over time, particular designers in working with contractors will get an understanding of what costs per square foot are perhaps within the tiers to help guide them one way or the other. But in regards to jumping from tier 1 to tier 2 or 3, they really are based on the treatment efficiencies and the ability to basically achieve the intent, which is water quality improvements rather than cost efficiencies.
Great. So jumping into tier 1, we have, as Wynn was saying, 98% to not greater than 98% TSS and greater than 80% total phosphorus. And the STPs that are in that category include infiltration basins, trenches and chambers and dry wells, bioretention, note designed to infiltrate, meaning no underdrain. So when the water goes in and infiltrates into the surface of the bioretention, it's not coming out anywhere. Dry swales, same thing. So dry swale just being a grass swale. It looks like a grass swale, but underneath the surface, you have a sand bed. So when the water is traveling through the swale, it's infiltrating, going through the sand, and then ultimately going away into the ground. Filters designed to infiltrate. So again, a sand filter, same exact idea as a dry swale, but just imagine a basin. Looks like just a grass basin from the surface, but when you dig down in, you're going to have, you know, a couple feet of good construction sand there, which is going to act like a filter and remove those pollutants. Simple disconnection. So we talked about disconnection over the surface. That is a tier 1 practice. That's, you know, it's not going to get you all the way there on a lot of larger sites. You're going to have to do things in addition to that, but it is a valuable tool for sure. Same with the disconnection to filter strips or vegetated buffers. So in order to prove your feasibility constraints for use of tier 1, so if you get to your site and you say, geez, got to look at all these tier 1s, which we just went over, and you know, you're going to be looking at these criteria, and these criteria in the manual. You know, what are the soils? So if the infiltration is less than 0.2 inches per hour, that really takes infiltration off the table. So it takes infiltration basins off the table, trenches, the chambers, potentially even a bioretention without an underdrain, a sand filter without an underdrain. So that limits you right away if you're in a situation where you have poor soils. However, the disconnection is still feasible. So you still have to consider, geez, well, can I disconnect my roof and sheet flow it over the grass? So I think a lot of times related to the soil conditions is the depth to the seasonal high groundwater table. If you have a high depth, and we're going to go into this in some detail in terms of the soil considerations, but if you have a high seasonal groundwater table, that's going to be a limiting factor for an infiltration practice. Presence of groundwater source protection areas, brownfield contaminated sites, and we talked about this, Hugo had mentioned this before the break. You know, it may not even need to be a documented sites. There's undocumented sites out there that also need to be considered. Definitely, you know, a tricky thing to navigate, I think. Hotspot land uses we talked about. So if you're designing a gas station, don't want to infiltrate that water, so you don't have to do a tier 1. Or any violations to the wastewater or public water supply rules. So kind of have to be plugged into those other evolving rules, because that, you know, could influence how tier 1 practices are applied.
So Andres, if you could just, while we're touching base on tier 1, that relies upon infiltration for a component of not only dealing with flows off the property, but also treatment. Hugo brings up a question with regard to pollutant removal and the fact that we are looking at primarily settling solids and contaminants associated or attached to those particular solids, and that we're not really looking at soluble contaminants that might just slip through the cracks here, for lack of a better way to describe the situation. But his statement or question specifically says, and will not remove or treat contaminants like chemically dissolved fluids, i.e. chlorinated solvents, petroleum, hydrocarbon fuels, etc. Correct? And I don't think we're in that particular area of treatment. So both Lynn and Andres, can you talk a little bit about, again, the fact that this is really a certain type of focus on treatment, and we're not trying to solve all the issues that are associated with both developed and undeveloped sites.
Yeah, I think that's a good point. I have a couple of thoughts on that. I think one thought is, you know, there is some research out there where, you know, these types of systems can be effective for removing things like metals. You know, in bioretention, you're seeing really good metals capture right up near the surface. You don't really need that much good organic soil right at the surface to trap, you know, and store metals. You know, things like, you know, probably the biggest thing that comes to mind is chloride, and chloride is a major water quality issue, and chloride essentially passes through everything. I think that we're involved in some research that's looking at, you know, potential chloride, how chloride behaves kind of flowing through some gravel wetlands that we're monitoring. I'm actually going to touch on that tomorrow when we talk at the end, when we talk about emerging issues in research. But I mean, that to me is a big one. And I don't think any of these things really, I think the jury's out whether or not they're really doing anything for chloride. You know, ultimately they could be storing some, but you know, it could just be detaining it, and ultimately it will be released in the future as it works through a system. So I think that's one as an emergent contaminant that I think is definitely an issue of concern, that, you know, that the BMPs that we're talking about right now aren't really focused on trying to mitigate that. And I don't know as much about, you know, the chlorinated solvents. I'm sure that there's actually some really good research out there that somebody's done on how stormwater BMPs perform. And I would actually be interested to look at that. And I don't know the answer to that question, if there is any performance benefit on something like a chlorinated solvent. If anybody knows, let me know.
Yeah, I mean, I would agree with what Andre said. You know, these are all pretty much passive treatment processes that are based on either a sand filter, some microbial activity, perhaps in a bioretention unit. But yeah, really focused on filtering out sediment and reducing overall flow to some degree. But there are certainly contaminants that are just not managed by these practices. And you know, if there was assumed to be a higher than normal amount of any particular contaminant, it would likely be considered a hotspot, and infiltration wouldn't be an allowed practice.
Yeah, and some of the alternative treatment practices too also do have some good data on related to the petroleum hydrocarbons. You know, where there's oil water separators built into those systems that are, you know, doing a decent job capturing some product. I mean, I'm sure not all of it. It would be the free product that it'd be capturing, but yeah. All right. Getting into the tier 2. So if we can't do a tier 1, we're looking at tier 2. So we're looking at bioretention, but we're looking at bioretention with under drains. So the water, stormwater filters through the media, and it's recollected out in a perforated drain at the bottom of the bioretention and then discharged to the water resource. So that's in a situation where you have a high groundwater table, or you have a contamination issue like we've been talking about, so the whole system is lined. So it's a filter. Gravel wetland, tier 2, very popular tier 2. Treats by chemical, physical, biological process, anaerobic conditions in the gravel. Plants, you get, the research has shown you can get very good pollutant removal with these systems for phosphorus and other contaminants, so sediment. Infiltration berms and media filter drains. These are two, there's a section in the manual that speaks specifically to linear transportation projects, and I'm not gonna get into details on that, but these are two practices which are specifically called out in that section that are useful for linear type projects when you're talking about roads and you have long systems where you have a long stretch of runoff that you need to treat. There's some tools in there which are specifically applicable for that, and two of them are this infiltration berm and a media filter drain. So in order to, so you get down into your tier 2 and you're gonna do this analysis, and you're gonna figure out if any of these bullets are impacting the ability of your selection, your tier 2 selection. And you know, it can be, there's a specific section in the manual, this is taken from the manual. The state is not going to be expecting you to rip up a wetland, a natural wetland, in order to put in a gravel wetland, for example. Or the state's not going to be requiring you to move a big water line, which might be running through the only available spot where you could put treatment. Also not going to require you to violate any zoning bylaws, anything like that, or interfere with any changes with existing land use permits like Act 250. I imagine that that can get a little dicey, a little gray, like in terms of, I just imagine there's some some situations which could come up on that. And then safety considerations, right? So if you can prove to DEC that, any of one of these conditions are present, then you are going to be looking at a tier 3 practice, which could potentially be something underground, say like an underground sand filter. Any thoughts on that, Win? Like just that, interference with material conditions of existing land use permits. I'm just thinking like how that could play out, where somebody could justify, well, I can't build this gravel wetland because it's going to impact my Act 250 permit, but I mean, you might be impacting it anyway because you're doing this development. So how do you, that seems a little fuzzy.
Yeah, it's an area that I'm sure there could be an issue that arises. I can't think of anything specific off the top of my head, but I could very well imagine a site-specific issue arising that would need to be discussed between Act 250 and the permittee and us in Stormwater.
So getting down into the tier 3s, so we're now looking at 50 to 60% phosphorus removal and 80% sediment removal. Dry swales, I'm saying not designed to infiltrate. So what that would look like is just this grass swale, 2 feet of sand, but then in the bottom a perforated drain. So when the water goes in, it's just basically filtering through, but it's being picked up on the other end, and it's not just going away. There's no infiltration. It's being picked up and returned to the stream. Filtering systems not designed to infiltrate. Again, same idea, big sand filter, but with pipes underneath. Collection, under drain collection, wet ponds, and then shallow subsurface wetlands, which I don't think are used very often at all. Because if you can do a shallow subsurface wetland, you might as well do a gravel wetland, it would seem like, to me, which is a higher tier. So I don't know. So before we move on, just any quick questions that have come up. So
Andres, Sarah provided a question about basically the design lives of these particular systems and whether we actually change the planting plans to reflect specific characteristics of the site in regards to toxins or anything else that wants to be treated as part of the system.
yeah, I mean, that's a great question, and that gets into a lot of the operation and maintenance discussion that we're going to have tomorrow about the approach for operation and maintenance and what the state requires in terms of reporting on operation and maintenance. I mean, there's a lot of visual cues which can lead a designer and inspector to understand how well a system is functioning, to be able to determine, what needs to be done to, maintain or, in some cases fully restore a system. So we're going to go over that. And I think the question about, do you encourage certain plants for certain situations? I mean, I've definitely read some literature on that. And I know that there are some plants which are specifically shown to do well for, say, metals removal. I think that in the context of the state permitting program that we're discussing, it would seem like the state would have no issues with developing a plan specific to that. I don't think that comes into a permitting question at all. The only requirement in the manual is that, there's specific planting plans developed for these things, but I think that they are relatively flexible. Right, so if somebody wanted to devise a planting plan specifically targeting, say, at a gas station, if there's a planting arrangement which is the plants are going to specifically do well for remediating metals and petroleum compounds, then I think that would be a great idea.
So Governor McCain chimed in regards to perhaps under Act 250 or some of your local approvals in regards to what limitations would preclude you from being able to utilize undeveloped portions of your property for stormwater management practices. And, you know, he mentions wildlife habitat specifically, or perhaps requirements that there be buffering between lots. Or I could think of one where we have primary agricultural soil retention under Act 250, where the district commission has allowed you a certain amount of impact, but no more. So, but again, that talks more about, you know, footprints of impact. What you would need to do is demonstrate that the tier 2 or tier 1 options couldn't fit within the area, and that you would be relegated to perhaps a tier 3 practice that could fit within the available area. So that's just an expansion of some of that discussion, perhaps, on what would allow you to work your way down in the tier process.
Another comment here from, let's see, David White. Possible example of conflict with Act 250 permit conditions might be, say, a requirement for retaining an area of archaeological resources. Yeah, I think that's that would be a good, certainly a good point. So I would think the Act 250 would win there, and that would be justification for tier 3, I would think.
So if we can just go up one question from Lynette with regard to heat absorption by stormwater covered in the manual. Why don't we talk a little bit about, again, just the cold water, warm water, receiving waters, and what that triggers within your design standards? Or maybe this will be something for tomorrow.
No, yeah, we can touch on that now. I think there's a couple things that come to mind. One thing is there are, with some of the BMP designs, say for the wet pond, there's a requirement now for a gravel trench. So after the water passes through and is treated, there's a design schematic now in the manual for a subsurface gravel trench. So you bring that water through gravel, which is in the ground, and it's intentionally designed to cool the water before it's discharged. I think a gravel wetland is also a good example. You know, it has some thermal mitigation benefits because the gravel is subsurface and it's constantly saturated with groundwater. That's the idea of how it works. And so when that stormwater comes in, you know, we'll get some benefit there to cool down before it's discharged. And then also, as Dave was mentioning, with the channel protection standard, when we talk about releasing that water, we have to be mindful of whether or not it's a warm water or cold water fish habitat. And in the cases of it being a cold water fish habitat, we're just detaining and releasing that water over 12 hours versus 24 hours if it's a warm water fish habitat, with the idea that the longer water would sit in some open basin, it's going to be heated up. I know it's a big generalization there, but I'm just saying that I think that's where historically that distinction between the 24 hours and the 12-hour time control of the channel protection standard, you know, has come from.
And the last one, go ahead. This one's just from Hugo. He's talking a little bit about hydrocarbon releases and the best management practice, STPs, within the stormwater management rules, as far as, again, just the effectiveness of those particular STPs and removing. And I don't think we are trying to demonstrate that we are going to be dealing with those. What I've heard in the nuances here is that Wynn indicated, hey, if you have something that is higher levels of runoff that is going to create water quality issues in the runoff, then you're likely a hotspot, and you are now going to be segregated into a whole different area with regard to surface water management there. And also on the other side, we heard that, hey, if it's just standard drips of oil coming off of parking lots or roadway surfaces, then we're probably at levels that are less than the water quality standards with regard to ultimately what's ending up in the receiving waters. So just points of interest with regard to you know, the type of stormwater runoff contaminants that we're looking to manage. And at the same time, we also recognize that in the hazardous waste world, it is a different world altogether from standard stormwater management, and we shouldn't try to confuse the two.
Yeah, and that there's a there would be a distinction, say, at a gas station, to where you might actually have a spill that you know should be treated as a spill with that whole protocol, versus just as you were saying, Dave, basically just the background stormwater, which, you know, if it's a heavily urbanized area with a lot of vehicle traffic and fueling positions and stuff like that, you're going to get just background levels of a contaminant. And I think that's more what we're talking about, not necessarily a spill situation that would require, you know, some action, you know, other than you know, outside of the stormwater program. All right, so that covers it for the practices. So the infiltration testing, I had mentioned that this was an especially important section because the infiltration, you know, the fact that the manual is focused around infiltration, the infiltration testing, how you actually do it, how you determine whether or not infiltration is feasible on site is definitely important. And so infiltration testing is required for Tier 1 practices. And the initial step is really to complete a feasibility assessment. And the criteria that must be in place is for infiltration. Underlying soils must have infiltration rate greater than or equal to 0.2 inches per hour. That could be initially determined by looking at mapped, published NRCS soils information on the soil data sheets. Then it's followed up with verifying by soil testing requirements. I'm going to get into some of the specific soil testing process in another slide here. And then setbacks and prohibitions for groundwater source protection. So we've talked about that a little bit. Infiltration may be specifically prohibited in areas where you have a source protection area for water supply. So you really have to be mindful about that. And if you're in that situation, you're going to be waived of having to put in a Tier 1 practice. The bottom of the infiltrating STP separated by at least 3 feet vertically from seasonal high groundwater table. That's what SHGWT, or bedrock. What is seasonal high groundwater? We're going to talk about that a little bit versus static groundwater. This is seasonal high groundwater, or bedrock. And you need to have a volumetrically sized pretreatment depending on the infiltration rate. So I remember we were talking about pretreatment, forebays, swales. For infiltration practices, we're talking, if it's a forebay, we're talking 25 to 50% of the water quality volume. So that's a pretty big, it's a big amount, because DEC is saying, you know, these practices are especially susceptible to failure if sediment gets into your infiltration chambers, and it's going to gum up the works and it's not going to function. It's not going to perform as intended. So we want to capture all that material ahead of time. So that's why we need a pretty big storage volume to do that. So in terms of the soil testing requirements for the infiltration practices, as I was saying, the first step is to do a feasibility analysis. And the idea is to screen unsuitable sites and reduce the testing costs. So this can be done at the initially at the desktop level, right? So the NRCS soil survey mapping. So this used to be on the A&R Atlas. You can go in there and you could turn on the soils layer and you could pull up an NRCS soil data sheet. I know that that data has now been moved, and that's a little unfortunate because that was really easy to access. I think in order to get that now, what I had to do was go into the NRCS Web Soil Viewer. If anybody's gone to that, I think if you just Google NRCS Web Soil Viewer, it will bring you to the tool where you can follow the instructions, get to your site, and you can pull that data sheet, and you can look, and there's published values in terms of the infiltration capability of that particular soil level. Previous written geotechnical reporting for the site, I think I kind of skipped over test pits or soil borings. I'm going to get to that next. But looking at available geotechnical reports is just a great way to do some screening at the desktop without even having to go out and dig anything. And not just for your site, but you can actually pull, on the ANR Atlas, you can pull up the drinking water layer, and you can find wells that have been drilled nearby. And if you click on the well, you can sometimes find driller logs in there. And if you click on the drilling logs, depending on the driller, they've actually done a pretty good job characterizing the soil. So that's just an awesome way to get that information ahead of time and look at that and try to prove out, infiltration without even going to doing any work. Test pits or soil borings, I mean, that's the best way, right, to go out and physically look at it in the ground, digging the hole. Warning, well locations on the Atlas are often in wildly wrong locations. Okay, so there you go, that's qualified. Don't put all of your faith in that. And also another just immediately relevant comment, somebody had mentioned they went to the NRCS soil site earlier this week and couldn't find the data sheets. Would it be possible to get some more detailed directions on where to find these? I'm gonna look at that because hopefully they're still there. I just pulled them a couple of weeks ago, but it seems like that's changing. And I don't know why they were removed from the ANR Atlas, but do you know when?
Yeah, so that's a tool that we rely on heavily ourselves. And I asked the folks that run the Atlas. So I guess NRCS themselves has requested that they be removed due to as they continue to make their site testing more finite. I guess they feel that some of those sheets are inaccurate at this point. And so now have requested that there's a link on the ANR Atlas that it'll take your screen area and push that as the area of interest over to the web soil survey. And then from there, I believe you go into the Soil Data Explorer. And then there's an additional step. I can go through it right now just to see exactly what those steps are.
Great.
That's helpful.
Thank you. So with the, once you do the initial feasibility analysis, the soil characterization and infiltration testing requirements. For infiltration practices, you need to have one infiltration test and one test pit per 2,500 square feet. And for linear infiltration STPs, so that would be, say, like an infiltration trench, a long, skinny infiltration system, you need to have one infiltration test and one test pit per 100-foot length. So it's not based on square footage, but it's just based on every 100 feet, boom, 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 you need to have a test. So the test pit requirements are a test pit or boring, can be either, needs to be advanced to a depth of at least 1 foot below the required separation depth to the seasonal high groundwater table. So I had mentioned in the case of infiltration structures, you need to have a minimum of 3 feet of separation from the bottom of your facility to the seasonal high groundwater. So that would mean you have to go 1 foot below the, total 4 feet, right? You need to provide soil profile descriptions and verification that the depth to the seasonal high groundwater and bedrock meets this STP separation distance requirements. And I'll mention for bioretention areas, and I think infiltrating sand filters, your seasonal high groundwater can be right up at the bottom of the filter layer. So I think the whole, just to give the context of why there's this variation with 3 feet and then less than 3 feet for bioretention and sand filters, is because in an infiltration trench, there's really, the stormwater goes in and the whole structure is really just designed as a conduit to get the water from the surface into the ground. There's no treatment mechanism in there, not necessarily. It's just say an open stone bowl or something like that. So the water is just designed to go in and go right to the groundwater. So we need to have that 3-foot separation so that the treatment can be occurring from the bottom of the structure before it reaches the groundwater table. In the case of, say, a bioretention area or a sand filter, the treatment is occurring within that filter layer. So there's a required 24-inch sand or specific soil media section, which is basically doing that treatment. So by the time the water gets to the bottom of that section, it should be treated. And that's why the groundwater can be right at that level, because then we can discharge it into the groundwater. That's my understanding why there's that discrepancy there. This is a highly recommended book for those of you that don't have it. I think it's actually free. I think if you were to Google this, this is by the National Soil Survey Center, NRCS, field book for describing and sampling soils. It's got a ton of detail. And I feel like it's got probably way more detail than is needed for stormwater specific work in terms of characterizing the soil, but it's definitely a good resource. And you know, you'll see this triangle is an excellent resource as well. Really just getting down to characterizing your soil. So describing your soil type, you know, describing the features of that soil. There's a right way and a wrong way to do this, and soil scientists will just tell you that I'm probably doing it all wrong, but I'm trying to just be consistent with the terminology. I think that so somebody can understand what you were seeing in the field, I think is the most important thing. And the most critical thing in terms of what we're interested in is how to define the seasonal high groundwater table. And there's a ton of information on this out there. You know, for wastewater designers, it's a huge consideration too. They need to be super aware of how to do this. So there's a lot of documentation about how to define the seasonal high groundwater table. And it's not always easy. I think in some soil situations where you have, say, a sand, it can be really tough, where you might have iron staining, which is not necessarily seasonal high groundwater table. You might also have a relic seasonal high groundwater table where maybe it was historically a seasonal high groundwater table, but now conditions have changed and maybe the groundwater is down 8 feet. You know, who knows? You know, so it's definitely not. It takes practice, and I think it takes experience in the pits to be able to understand where it is. But you're really just looking for this modeling, which is indicative of a rising and falling of a groundwater table. That's really what we're interested in. And so it's not just this, you know, you're digging the pit and looking at where the water is, but you're looking at evidence of where the water is over seasonal, you know, at a seasonal high. And that's really our baseline of where we're working from in terms of the stormwater. So the infiltration testing methods, we're looking for a field saturated condition assessment. So what that means really is we want to know how infiltration is going to be performing over time. Say when you have your stormwater featured there and you're putting a lot of water into it, is it going to continue to infiltrate once everything is saturated, or is that infiltration going to trail off over time? And so to be conservative, whatever your measured rate is in the field, the state requires you to divide by 2 as a factor of safety. And there's multiple acceptable testing methods in the manual. Some of them are, I'm gonna mention, we use this Johnson permeameter. There's also something called an amusimeter. There's a double ring infiltrometer. There's a falling head test, which I think is more of the traditional method. Interestingly, the falling head test requires pre-soaking. Pre-soaking is very problematic from a practical standpoint, because what it means is technically you're supposed to be out to the site 24 hours before you do the test, and you have to actually pre-soak the hole, which is not very realistic for those that have done this work. Like, you schedule a contractor and you go out that day and you need to do the test. I know that DEC's been flexible in actually accepting. There's some research out of Oregon where somebody had done a test, and Kevin had shared this with me, where a local engineer had found some good research that demonstrates that there is a way to basically not do the pre-soak and still feel confident with doing a falling head test without doing that. And so it's a little bit of a modified method. But, you know, so that could be an option if you're doing the falling head test and can't do the 24-hour pre-soak because it's impractical to get out there, you know, 2 days in a row. And I think after this, we just have one more section, which is going to be pretty straightforward. It's just the administrative form section. So any discussions? I'm looking at looks like a risky trench. Yeah, it was. One copy may be ordered. Okay, great. Yep. So there's a link for the NRCS distribution center. Entering the keywords field book and then order by phone. So that's great information. Thanks for sharing that. And I think that's, I'm not seeing any other questions on that. Does anybody, Dave, do you have anything to add? Anybody else want to add anything on that section before we move on?
No, I'm good for now. Thank you.
All right, so the last section here for the day, just going to go through the administrative forms. And I don't believe there's been any changes to this, but if there's anything that you guys are now requiring new that you need to correct here, please jump right in.
Okay.
Really just talking about the permit application materials. There's a link here when you get this presentation that will bring you right to the page where all the 2017 application materials are kept. There's some great examples on there in terms of, you know, mock site examples. If you're doing an application for the first time and want to put together the proper forms in the proper order, the DEC also has a good reference document on that. Win, is that still on your site, the one that goes through all the application components?
It is, yes.
Yeah.
Yep. And we update that fairly regularly as needed.
So in general, you have these 7 components. So there's the notice of intent, and then the supporting attachments that go along with it. The attachment 1, narrative, the workbooks, attachment 2, attachment 3, the worksheets, attachment 4, the modeling, attachment 5, the plans, and then the application fee, the all-important application fee, right? So the notice of intent, so we're looking now at general permit 3-9015 and individual permit. So again, we talked about we're in a state of flux here. On the bottom, general permit 3-9050 will now cover new development, redevelopment, 3-acre sites, discharges to impaired waters, cover everything starting December 1st, 2020. So the 9015 is going to be retired, right? But currently, how it is presently, there's a 14 public day notice period for a general permit and a 30-day public notice period for an individual permit. In one of the newer things in this 2017 manual, basically site balancing and or net reduction design strategies are eligible for general permit coverage. So what does that mean? Site balancing is essentially where you're you're treating one area that you may not be required to treat in exchange for not treating another area that you are required to treat, and such that the net benefit is the same. And that used to require that you would get an individual permit through the agency, and it's now allowable under a general permit. So it's made doing that site balancing easier. The situation where you need an individual permit, so if you're discharging in a stormwater impaired water, the A&R Atlas, there's a coverage for that. You can see where those are. Or if you're using an alternative STP, we've talked about some of these alternative STPs where the state has gotten this approval that it meets the standard. You need to seek an individual permit for that. And the final requirement, you need to notify adjacent landowners. That's not necessarily a requirement for a general permit. So notice of intent, I think the newest thing on this is that you do need to check off boxes with respect to whether or not you're working in a regulated wetland or wetland buffer, regulated floodplain or river corridor, or within a stream channel. I think it's just a way for A&R to coordinate on reviews, making sure that things are caught ahead of time where there's other regulatory requirements. You also need to report on whether or not you're in a hotspot land use or activity. So getting into the attachments, so the narrative attachment, you know, really that's just, the key to that is you're just explaining the project first. For Win or any of the other reviewers that have no idea of what this project is, it's introducing them to the project, giving a little summary of like what the project is, what the existing conditions are, what's proposed for treatment, how much impervious area you're talking about. And the A&R has a great template. It's actually, this is the template, but this is available on the website to start from. So it tells you exactly what you need to have included in there. And in addition to the narrative, the project location map and a soils map is part of that attachment 1. Attachment 2, so the workbook. So we're going to get into this tomorrow. So there's a series of Excel sheets that the DEC has that make it a lot easier now to plug in the information that you need, that the DEC needs to see to figure out your volumes, to figure out how you're complying with the manual. The attachment 2, the workbooks. So the STP selection tool, we're going to actually look at this first tomorrow. But that's really that's your first stop. So what that is that's a worksheet that you're going to go through. That's basically going to tell you, by you answering these questions, whether you're a tier 1 or tier 2. And if you're neither one of those, then it's going to give you a space to basically put in your justification for tier 3. So that's your first stop. Standards and compliance workbook, although it's part of attachment 2, you really can't fully fill that out until you fill out the worksheets, which is in attachment 3. Okay, so that is, the standards and compliance workbook is really the Bible. That is like the main document where you have all your numbers together, and the way that the formulas work in this workbook are, it's gonna tell you whether or not you are complying with the standards, or whether you need more volume, or maybe need to make some changes. And so in the exercise, we're going to go through that. And for those of you that have been around working 2002, no more Schedule A's, no more water quality calculation worksheets, no more groundwater recharge calculation worksheets. It's built into the standards and compliance workbook. This is just the little snip of this STP selection tool. This is the first one I was telling you about. So this is what it looks like. And this is in your resource packet as well if you want to start looking at this before tomorrow. But essentially it's yes or no questions, and the cells change based on your answers. And it's going to tell you whether your practice is available for, essentially what you're going to do is you're going to answer, you know, can you do a tier 1? If you check yes, you're done. If you don't, then you're going to go through all these other questions. And it's going to tell you what practice is available. And if you get down to the bottom, like I was saying, and you can't even do a tier 2, then you're going to have a space at the bottom to provide written feasibility justification for why you can't do a tier 2 practice. And that's what it's saying right here. Provide written site-specific justification below. Standards and compliance workbook. So just so you know how it works, there's a tab, which is the instructions tab. And it tells you that the blue boxes you need to fill out. The yellow boxes are optional. Gray boxes are calculated. So when you open it up, there's going to be a tab, and you do a tab for each discharge point. So if you have 3 discharge points from your project, you're going to do a tab for 1, 2, and 3. You're going to fill out your land use information. You're going to fill out your precipitation information. You're going to fill out the latitude, longitude, the project name, all this. We're going to go through this tomorrow, but this is just a snapshot of what it looks like. Moving down a little further, once you fill this out, it's going to tell you, here's one of your standards: recharge, standard met, yes. If it didn't meet, it would say no, it would be in red. Doesn't always work exactly like planned, and that's one of the things we're going to look at tomorrow. But just to give you an idea of flavor, you can see there's gray cells. Here's a blue cell, so we're going to have to go here and look at this. Is all impervious treated by disconnection, yes or no? And then space right here, these are drop downs. So when you drop, there'll be embedded data right here. So tier 2 or tier 3, if you're in a situation where you've already proven out you can't do tier 1, you're going to do a drop down and you're going to get your tier 2 here. You're going to enter your water quality volume here, and it's basically going to auto calculate your volumes and tell you if you've met your standards or not. And then the worksheets. So I was saying the worksheets have to be done before the workbook. And so the worksheets are the specific worksheets for the practice. So there's one for the post-construction soil depth and quality. So that's just like more of a checklist, making sure that you have all the appropriate information for the soil standard, if you remember that, the 4% soil standard. The STP worksheet, so say if you're doing a gravel wetland, you're going to do a specific worksheet for the gravel wetland. You're going to enter the volume of it. You're going to enter essentially you're going to get the treatment volume that gravel wetland is providing. And then you're going to take that number and you're going to put that into the workbook. So that's why you need to do the worksheet before you can actually put that number into the workbook. Also in attachment 3, you're going to have your soil characterization and testing information. Attachment 4 is going to be all the modeling information. So it's going to be water quality storm modeling. So that's the 1-inch storm modeling, where it's also going to be the channel protection modeling. So the 1-year 24-hour storm event model, and the higher flow models, the 10 and 100 detention standard modeling, and then any downstream analysis. And we talked about that before for the 10-year or the 100-year. In a situation where you're trying to prove out that it's acceptable for you to have an increase in discharge from the site for a 10-year or 100-year, you have to provide that full downstream analysis, which is going to be more of a narrative and kind of more extensive modeling of not just the site, but also conditions downstream in order to prove that out. And then attachment 5 are the plans. So you have your existing conditions plans, your proposed conditions plans, all your construction details. And I know that DECs, I think, is pretty specific. They don't really want any irrelevant details necessarily, if you can help it. They don't need to see wastewater details. They don't need to see structural details. They just really need to see the stormwater details. So if you can think about that ahead of time and organize your sheets that way, it'd probably be better, because every sheet that goes in then needs to be recorded, and it's right, Win? I mean, I think that's what you guys say, right?
Yeah, that's right. Yeah, and I guess changes to unneeded information would just be another change that has to get recorded.
Right. Good point. So in the plans, the sub-catchment boundaries are critical, and I think just a note on that, you have to make sure that your boundaries are correlated to the model, which is in attachment 4, so that somebody could pick up the plan and see your watershed boundaries, and the same label is going to be in the HydroCAD, so they can see, you know, what your you know, you can correlate between the two. Sometimes that doesn't happen. And so that's important. And delineation of impervious surfaces, new redevelopment, existing. A lot of times that's nice to just have a standalone plan, sometimes color coded on a complicated plan where you might have all 3 of those situations together. You just have one color coded plan. The time of concentration line, that's one of the inputs to the hydrologic model. The state would like to see that for each subcatchment area. And then any sensitive areas, water resources, buffers, any mapped wetlands, drinking water supplies, source protection areas, anything like that should also be included on those plans. And the application fee with the NOI does a nice job now, auto-calculating. You put in your impervious area, it will auto-calculate your fee based on the administrative fee, which is a flat fee, but then the the review fee is based on the amount of impervious surface, and also whether you're in a class A or B water. You're going to pay more for a class A, so you do actually need to understand if you're in a class A or B. But then if you answer those questions, the fee calculates on the NOI, and the state has now been moving to submitting payment through the online portal, which I think is making things a lot easier. And actually, you're also accepting applications through the online portal too. Is that correct?
Yeah, that's right. Yep.
So
preferably, really.
And there's a whole process on that to set up with, actually, I'm going to go through that a little bit tomorrow for the inspection stuff, about how you get on to the A&R online, set up an account, get in there. But, you know, everybody's going to be migrating to this digital submission, which is great, makes things a lot easier. And just repeating on what noted about not providing extra information. So building footprints would be definitely included. What I was referring to as extra information would be something not relevant to stormwater. So a lot of times with a plan set, you might have a sheet which just has the details for the wastewater system. So the mound or whatever it is, totally unrelated to the stormwater. You know, if that's the case, you don't really need to include that sheet because wind doesn't really need to see that. So not related to the buildings, all that is really critical, but just something which might not be related to stormwater in terms of constructing it is not relevant to his review. So that's it for day 1. Trying to see if we got any other questions here. So Wynn put up, I can see a link about creating the area of interest on the Soil Data Explorer to get to the soil fact sheets. So you guys can see that. Can site balancing be used to deal with impervious areas that cannot be collected or treated, such as a portion of driveways that are in a right-of-way, downgradient of a project? Can you overbuild an upgradient STP to account for these downgradient areas? And I think the answer is yes.
Yes, that would be fine. Site balancing is allowed.
I think as long as you're within, I'm trying to remember you have to be within the same discharge point, right?
Should be same receiving water at the very least. And there is we would look at what is being site balanced for, so
right.
A heavy trafficked parking lot wouldn't necessarily equate 1-to-1 with a roof, or as an example.
And the water, the receiving water, just for an example, you might have on a big site, you might have multiple receiving waters. Maybe one goes to Bartlett Brook, the other one goes to Monroe or something like that. And in which case, that could be complicated if you're site balancing one watershed to another, it might not really be a valid site balance. So I don't know if the DEC, they probably wouldn't allow that in that case.
Right. Yeah, it would not count towards site balancing.
Do you have to own all the land in order to use the site balancing? I would think you would.
It has to be in the permittee's control. So either ownership or I guess an easement would work as well.
Okay. Dave, any thoughts or any other thoughts from anybody else?
I was just picking up one word on the site balancing question, and the fact that when you're doing site balancing, you're basically taking a portion of impervious surface that's not being treated under existing conditions and then gathering that and then treating it in lieu of something that you can't grab as far as treatment is concerned. But have you ever had a situation where you try to provide extra level of treatment through either STPs in series, perhaps, where perhaps because you don't have some other site, I guess I'll leave the question at that.
Yeah, I think the only time that could work really would be if, you know, in the case of a redevelopment, if the required volume were less than the full water quality volume. But you're not going to get credit towards the water quality treatment standard for a volume that would be beyond what would even reach it during the 1-inch rain event. So, you know, just making a practice larger wouldn't necessarily, you know, if it's beyond what would be required to treat the full water quality volume, that wouldn't apply towards site balancing, unless it were larger because it's, you know, receiving water from a larger draining area. That's not all required to have permit coverage.
There's one more question there, a long one.
Yeah.
Yeah, I think, Nick, that's a good question. And one that we don't have an answer to yet. That will probably be discussed internally, and we'll go one way or the other on that as the feasibility analyses are put together and submitted. But I don't have an answer to you on that right now.
So that question was in the chat box, and if anybody wants to understand what the basis of the question was, but at this point we don't have a good answer. So that will come in time, though.
Well, I think with that, if there aren't any other questions, that's going to conclude for today. So I really appreciate, special thanks too to Win. Thank you for jumping on. I hope you're available to jump on tomorrow too. It's definitely nice to have your perspective, and also Hugo and Lynette as well. Just to have this DEC reference there is super useful. So thank you guys.
Yeah, thanks for putting this together. Great.
So I'll hand it over to you, Christine, I think at this point.
Yes, thank you everyone for today and joining us. Please do sign back in briefly before you log out, so I know you stayed with us throughout the entire training. If you need credit for your trainings, for this training for your professional certifications. I have gotten a lot of messages about the recording. I will distribute it to anybody who is in attendance. I will need some time to work through that. This will be the first time we'll be doing the recording and doing the distribution, but it'll be just for registrants here for the course today. If you do need training certifications, again, I'll be going through the chat list here afterwards and reaching out to you with that information, coordinating with that. But again, just give me a little time to follow up with you about that. those are the only things I have at this time. So I believe we're on for starting 8:30 tomorrow morning. Is that correct, Andreas? Yep. Okay. So we'll see everybody tomorrow morning at 8:30. Thank you again.